Have you been using Power BI for a while, but you still don't fully understand the data model and how to make it work for you? Well, this week we're going to talk about some concepts to improve your data models and power up their performance. So let's get started. As always, if you're finding my videos for the first time, make sure you hit like below and also subscribe and hit that notification bell button so you'll be notified of future videos. So this week we're going to talk through the data model and some key concepts to think about when creating your data model for the first time. We're going to talk through sort of the data structure and how best to structure your data for use, what DIMs and facts are and how they relate to a star schema, which kind of powers the Power BI model completely. So to get started, I have some data here which I have got from the CPL, the Canadian Premier League. So thank you to the Center Circle Inside datasets. You've got free access to stats perform summaries. So in this, we'll talk about data structure. So the first thing to look at when you're creating your data model is the size of your tables. So as you can see here, we've got a player by game table with all the data. So far, this is just for this season, so the 2021 season. But what you can tell is if you go across, there is a number of columns here. One thing to think about is like, do I need all of these columns? And is there a better way for me to structure this data set so that it works better when I have more and more data coming through? What you can see first of all is that there is a lot of what you could call junk data at the start here, where you have player IDs, names, full names, positions, etc. You've also got team information and then Opta data, league data, and so on. What you can do is you can break down that data set to being smaller. If we also look at the team by game dataset that we have here, it's very much the same where you've got a team, all their information, and then all the data about that team. And you can see this one's even bigger than the player dataset. So as an example, if I was to be creating a report mostly just on shots, maybe I just want to keep the information on shots. So I've already created a dataset outside of Power BI that is limited to all the information that we need. We have our team IDs, so we can link to a team table, and we have all the shots that they've taken. We have the date, so we can make sure we can relate that to games and who they were playing against, or a game ID, so we can find the exact game. But in the end, this is all you would need. One other option you have is using Power Query. So if I went into transform data here, what I can do is go to my team by game table here, and I can say all I need to keep is a certain columns. So what I could say is I need to keep these, or I need to remove these columns, for example. And you can just go here, remove columns. This will add a step in your transformations, but that will remove the columns from your dataset quite easily. One that will help with the size of your data model, and it will improve performance as the size of your dataset grows in terms of number of rows. The second thing we need to talk about is DIMs and facts. So DIMs and facts come from data warehouse terminology, but they relate to two things. They're dimensions and fact tables. So your fact tables will be things just like your team by game or your player by game tables here, and they'll have all the information on metrics or things over time. Whereas your dimensions are things that describe the metrics. So that would be things like here. We have a player table, which we can link to our by game table to describe the information that we have in here. Or we have a team table that we can do much the same way to our team datasets. And these all work together in the background in Power BI in what's called our star schema. So we use the star schema to link our tables together. So if we were to, example, create a schema here, we have our team by game table and we have our team table. And what we want to do is link them together somehow. So what we can do is use our team ID, ideally from here to here, to find our data. So if we scroll down our CPL team by game and find the T's, as you can see there is a lot of information here, which also makes this difficult to find everything. We can keep going and we've got our teams here. Ooh. So we have team ID here and we have team ID here. So if we drag this across this direction, it'll create a relationship between the two columns. And as you can see, it shows up here. What you also have is an arrow to show the direction. So that means that the teams here in the CPL teams table will filter that of the team by game table. So if we go back to our report, and if we create a simple visualization, and let's just create a clustered bar chart, put a team name on the axis, let's drag this to the middle, make it a bit bigger. If we now go to our team by game, which is, let's double check what we used, yes, team by game, and say we take, we'll find shots on goal, which, well, let's just go shots total, add the values, and we can see here now we have all our total shots by team. If we were to remove this, relationship, let's see what happens. Now we get what's called a Cartesian product, where it will just sum everything together for every team that we've added. That's obviously not what we want, and if we were to keep this as a model, we would have to create some complicated measures to be able to create or view the data that we're wanting to look at. So by having this very simple relationship, it makes our visuals really easy to work with. Now if we went to example for the player by team, we have the same option. And what we can do is, or player by game I should say, we can find our player ID here and we have our player ID here. So if we add that on, we have this information. So now if we went to the same chart, let's remove our team information, and now if we add players, and so we'll go with a player full name for example on the side, and we'll go player by game, and again let's just add shots as our value, and we can see that our players pop up and who have the most shots and who has nothing. What we might also like to do is see by team. So what you could do is you could add team ID here just simply onto our chart, and that would color by team. But as you can see, that's not really telling you who the team is. So this is where we can create what we might call a snowflake dimension. So we could drag this to here, for example, and we could filter this way. So if we added from our teams and we added a team here, we would see the colors appear for the team. What this would also allow us to do is to add a slicer to the side of our page and to choose a team, and it would filter the players of that team. So let's say for example go to Pacific. Here are the players from Pacific that have had shots, or just in general. If we went to Ottawa, Cavalry, and so on. So now you can see the power of dimensions and what they can do for you, or facts and dimensions and what they can do for you in your star schema. We can also, if we would like to, you could filter this way. But in terms of this method, this is one way of doing it. And as you can see, the model can become quite complicated if you have a lot of facts in your data set. But here you can see, so far this is quite simple. If we were to then create our links here between all our other data sets, let's find player ID again. If we go to all tables, we can start to see how it grows. In this example, you can see we have a bidirectional filter. We don't really want that, so we can use a single, but sometimes that's not valid for certain relationships. Having it both is not an issue, as you could use it both ways, and that's up to you. The one thing we don't want, and this is an example that would come back if we were to go to here. If we look at this relationship that we have, you can see that it's many to one, and it's a single direction. If we were to filter a different way, and let's say we were using just our player totals and our player by game and our team by game. If we were to filter this way, one issue we have is this. If we were to filter team ID and team ID, let's see what we get. You can see there is a many-to-many relationship, and this makes it hard to distinguish, and sometimes you will get some different behavior that starts to occur when you have these many-to-many relationships. This is something you want to avoid as often as possible, and so by using your dimensions and your facts, that's one way of doing that, is because you will always have a unique value or a unique row for each dimension that you have. So for now, this is one way, or this is the best way of creating your model to help power the performance of your model and make it easy for you to create your visuals and your reports. I hope you found this video useful. If you did, again, make sure you hit like and subscribe below. Otherwise, I look forward to seeing you guys next time, where we will continue to power performance through data. Thank you.